Hi, welcome to my video on the average rate of change, linear function number 2. Let's do some problems to illustrate the average rate of change of linear functions. Number 1, in 1993, a house was bought for $78,000. It was sold again in 2003 for $124,000. Find the average rate of change. Well, I'm going to let T be time, and I'm going to let G be growth. So we have T1, G1, so that's time when we have a growth. That's on the first year, so T2, G2 is the time and the growth in the second in later years. So what we have is, we have in 1993, we have $78,000. That's what the house was bought for. And in 2003, it sold for $124,000. So this is dollars, and we have the years. So the rate, or the slope, the rate of growth, so the rate, which is the slope, is, again, it's G2 minus G1 over T2 minus T1. So that's 124,000 minus, this is G2, this is G1 minus 78,000. And the time is 2003 and 1993. And that gives us, if you subtract here, you get 46,000. And if you subtract 2003, 1993 is 10. And that gives us 4,000. The zeros cancel off, so $4,600 is the average rate of growth each year. So this is the number of dollars per year. Number 2. What is the average rate of change between any 2 points on? And we have negative 10x minus 2y plus 6 equals 0. So that's a linear function. X and y are powers of 1, so we have a linear function. So we're going to solve this function for y. So negative 2y equals 10x minus 6. So what I'm doing, I'm solving it like y equals mx plus b. So we divide by negative 2 on each side. So y equals negative 5x plus 3. So that means we have a slope of negative 5. We have a y-intercept of 3. And the average rate of change is the slope. So the average rate of change, so the average rate of change is negative 5, which is the slope. Again, I solved the equation for y and picked up the slope. The slope is in front of the x. Now, another way to represent this is in the function notation, f of x equals 4x. The average rate of change from a to b is given by this formula. The slope formula is the same. So we got a fb minus fa all over b minus a. So what that is that we have an a and the f of a. And the other point is b and the f of b. And the f of a and the f of b is the same. So if I call that a y here, that would be y equals 4x. This would be a y, an x and a y. So the f of a is the y value at a, and the f of b is the y value at b. So let's find the rate of change from 2 to 4. So the f of 2 is, the f of 2 is 4 times 2. So the f of 2 is 8. So f of 2, 4 times 2. And the f of, we're going to look at the f of 4. The f of 4 is 4. Again, f of 4, x is 4, so I put a 4 in. I get a 16. So this is a 2 and an 8. And this, the f of 4, for x, or a or b is 4. So we got a and b's, or function notations. I would look at it. This is y2, y1, x2 minus x1. So this is a 16. So according to this, the slope is, this is 16 minus 8 all over 4 minus 2. So that's 8 over 2, 4. But even though I did it using the function notation, f and f of x, remember this equation here is y equals 4x. So this equation is y equals 4x plus 0. It has a slope of 4 and a y-intercept of 0. It's a linear function. Because it's linear, the slope is 4. And I worked it out. So no matter how you look at it, from what perspective, if you use y's and x's, or a, f of a, b, f of b, you still come up with the slope of 4, and the slope is 4 because it's a linear function. So even though I worked all this out, I could have said this is a linear function, slope is 4. Well, no matter what I have here, it's going to be a slope of 4. Average rate of change is the slope of a linear function. Now we have another question to do, and I thought this was interesting when I made this one up for the students. I have 3 diagrams, and each of these diagrams represents a person walking from A to B. So this is the starting point at A and arriving at B. So this is Harry walking from A to B. This is John walking from A to B. And this is Jim walking from A to B. But you notice that they walked differently, and let me explain. Find the average rate of change or speed for each. So no matter, the 3 of these start at A and end up at B. So the 3 of these are starting at, and this is distance and this is time. So right here the time is 0, and your distance, you say this is the distance that you're walking from the start point, you're 5 feet away. And when you end up after 5 seconds, you'll be 20 feet away. So if you notice, they all, the 3 of these start at A and end at B. So the 3 of these are starting at, this is T and D distance, so it's 0, 5, 0, 5, 0, 5. And they all end up at 5 seconds, 20 feet. 5 seconds, 20 feet. That means that they all have the same slope. So the rate of change is your slope. And the slope is y2 minus y1 over x2 minus x1. So that's 15 over 5. So on an average, this average rate of change, or the speed, or the slope, is 3. So that's 3 feet per second. S is second. But they all walked differently. Notice that Harry started and walked continuously. This is a line. So on this line, the slope is 3. The slope on this line is 3. So if you go up 5 and right, so if I go up here I'm saying this could be right in the middle here. So if I go up 5, Harry will rise from 5 to 20, which is 15, and he'll go from 0 to 5 seconds. So Harry walks steadily at a pace of 3 feet every second. But if you notice that John doesn't, John at 0 to 2, John from 0 to 2 didn't walk at all. He didn't move. Because this is 0 and this is 2. This is the horizontal distance, so the distance never time change, but this is horizontal line. So from 0 to 2, there was no walking by John. He didn't start yet. But from 2 to 5, from 2 to 5, he started to walk. But notice, in order to get to B in 5 seconds, he had to walk faster. So that means he walked 15 feet in 3 seconds. So that means to make it up, John had to walk 5 feet per second, even though he didn't walk in the first 2. But to make it up, he had to walk faster. Notice the slope is steeper, so he had to walk faster. So notice the average rate of change is the slope of the line between where he started and where he ended, no matter how he walked. And Jim walked different. Notice that Jim started, as time went by, Jim was walking right here, and a little bit slower, because it's not so steep as these two. And then at 2 seconds, he stopped for 1 second, and then he started again, and it was steeper too. As you can see, in relation to this line, this one is steeper. So Jim, from 0 to 2, from 0 to 2, he went up 5, right 2. So 5 over 2, so that's 2.5 feet per second. So in the first 2 seconds, he walked at 2.5, which is slower than 5, which is slower than 3. And from 2 to 3, from 2 to 3, time is going by, but the distance never changed. So he was not walking. He didn't walk, he stopped. Okay, he stopped. Then, to make up for that time, from 3 to 5, from 3 to 5 seconds, from 3 to 5, he went from 10 to 20, so he went 10, and the time up from 10 to 20 is 10, and he went to right 2. So that means he walked 5 feet per second, which is, let's see, yes, 5. So that's same as what John, but this slope here is the same as this slope. It looks a little bit different, but because he stopped for 2 minutes, he only stopped for 1. But at the end, John and Jim had to get to B from 3 seconds to 5 seconds. He walked 5, and he walked 15 in 3, so that's the same as 5. But what I'm trying to illustrate is that the line here is from A to B is the slope of this line, which is 3. So the average rate of change for Harry, John, and Jim is 3 feet per second. But notice it's the average. And the average is the distance divided by time from the beginning to the end, even though they walk differently. The 3 of them did the average rate of change. They walked different, but their average was the same, hopefully. And again, a good illustration here. Harry walked 3 feet per second for every second. He walked at a steady pace, whereas John and Jim didn't. But again, note, they both walked. They both walked as Harry did. The average rate of change is the same, 3 feet per second. I thought that was a good question to illustrate the average rate of change when 3 of these people walked differently. And that brings us to the end of the first video. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.